In this video, we'll talk about a very cool feature in C# called LINQ. It's not a character in the video game, but it's still very cool. LINQ uses a number of other C# language features. In particular, the query results are usually implicitly typed using the keyword var. The projection part relies on anonymous types and tuples. And LINQ functions are implemented as extension methods to array and collection classes. And many of these extension methods have delegate parameters that take lambda expressions as arguments. If you forgot about these language features, it'd be better if you review them a little bit before proceed with LINQ. With that out of the way, let's talk about this example. Here we have an array of names, and suppose we want to find all the names that start with J and put them in alphabetical order. This is what we would do with our LINQ. We would first create an empty list, then we would iterate through all the names in the array. If a name starts with J, we add it to the list. And after the for each loop, we sort the results. It's not a difficult thing to do, but it will take some code to do it. Now, this is how we could do it with LINQ. We can simply say from name in names, where name starts with J, then order by name, then select name. Or we could say kind of the same thing, but with methods where order by and select. In both cases, we can immediately see the similarity to SQL, and that's indeed what LINQ is. It's a SQL-like syntax that we can use to query objects in C# as opposed to query data in a database. Before we talk more about LINQ, let's quickly see how it works. So I have already written these two LINQ queries here, one using the query syntax and one using methods. And in both cases, we'll use a for each loop to loop through the results and print them out. And since we have only 4 names and only 2 of them starts with J, we expect to see John and Jane in the results. And since we are doing order by, we expect to see Jane appear before John. And if we run this code, it indeed is what happened. The first query gives us Jane and John, and the second query, which is the same, just using a different syntax, also gives us Jane and John. So, as we just saw, LINQ lets us query and transform data using a SQL-like syntax. There are 2 major benefits of LINQ. First is simplified coding. Like in our example, previously it takes 4 statements, and with LINQ it's only 1. And this is just a simple example. Usually with more complex requirements, we'll say more code with LINQ. Another important benefit is that it gives us a standard way to access objects, relational data, as well as XML data. In this video, we'll talk about LINQ to object, which is basically using LINQ to query C# objects in arrays and collections. Next week, we'll see how to use LINQ to query database data. The results of a LINQ query is a collection of data. The collection implements the IEnumerable interface, so we can iterate the results one by one using a for each loop, like in our example. And in this example, we know each result is a string, so the result would be a collection of strings. But later we'll see when projection is involved, the type of the individual result would be an anonymous type or tuple. So using var for the results type is usually necessary. The similarity between LINQ and SQL is obvious, but let's take a closer look and understand the key difference between LINQ and SQL. Namely, LINQ is for objects, where SQL is for rows and columns. For example, here, names is the name of an object collection. And we're basically saying here, for each object in this object collection, call this object method. And if it returns true, put the object in the result. And later, when we do OtherBy or projection, we either do it with the whole object or with some object properties, as we'll see in some examples later. And as we saw in our example, there are two ways to use LINQ, with either the SQL-like query syntax or the more C#-like method syntax. Or well, it's not C#-like, it's really just C# code. Regarding this two different syntax, the first thing to know is that all the LINQ functions are actually implemented as extension methods to innumerable collections. So the method syntax is kind of the more fundamental way, and the query syntax is just built on top of the method syntax. The benefit of the query syntax is that it's more concise and often it's more readable, especially when things like drawing are involved. However, not all extension methods are available in query syntax, which means sometimes we have to use method syntax. If you don't want to remember two syntax and just want to stick with one, use the method syntax. The downside, of course, is that the method syntax is more verbose. As we can see here, you'll need to write lots of lambda expressions comparing to the query syntax. One more thing about LINQ is the so-called deferred execution. This basically means that LINQ queries are not executed when are defined, but they are executed when the code tries to iterate through the results. Take this for example. So we are defining a LINQ query here, and at this point, the LINQ query should give us John and Jane, but let's say we change Tom, which is the third element in the array, to Jack. Now notice that the query is defined before the data change, and if we run this code, we can see that it actually gives us Jack, meaning that this one really just defines a query, but it's not really running it. In other words, the results set is not populated, and the query is only run after we try to iterate through the results. So this is the reason we actually get Jack in the result after the query is defined. Now, if we want the so-called immediate execution, meaning that as soon as we create a query, we run it, we can simply call toArray or toList, or one of the methods like count. That means we can do something like this. We can put and then simply say toArray or toList, or one of those aggregation functions like count, and that will immediately run the query and put the results into results. Okay, so now that we have a general idea of LINQ, let's formally define the LINQ syntax and use it to do some common queries. This is the LINQ query syntax. We say from, and then a name for an item in the collection. This part is basically a variable name, like in the for each loop, we say for each var some variable name, and this is the same thing. So in other words, we can give basically any name here because it's just a variable name. And then the name of the collection, and then where, then conditions. The conditions is basically a Boolean expression returning either true or false. And the projection part is different from the SQL syntax in the sense that it's at the end of the query instead of at the beginning. In SQL, we would say select something from, but here select is at the end. My hypothesis is that in C# we need to define a variable first before we can use that variable or refer to the property of the variable and so on. So that's why select is at the end and from is at the beginning to define the variable. Anyway, in select, we will either select the whole object by using the variable name or select some properties of it using either the anonymous type syntax or the tuple syntax, as we'll see in a moment. Now, speaking of the method syntax, it's really no different from regular C#. The main thing we need to know are the extension methods that are added by LINQ, and they are defined in this class called enumerable. And we can see there are lots of extension methods defined here for LINQ. The documentation is a little hard to read because all of them are generic methods and many of them take generic delegates as parameters. But fortunately, most of the time we'll just use only a handful of them, like where, select, OtherBy, and so on. And after a little practice, you'll quickly get used to it. So let's do a few common queries using LINQ. The example we'll be using is this one. I already have some code here. So in this file, I defined a few classes. Employee class with properties ID, first name, last name, date hired, and supervisor ID, and project class with ID name, leader of the project, which is which is an employee, and the members of the project, which is a list of employees. And I also have a company class, which has two properties, employees and project. The constructor of the class will create 4 employees, John, Jane, Tom, and Bob, and put them in the employee list. And it will also create 2 projects, Firestone and Blue, and put them in the project list. Now, if you remember the SQL example we did before, you can see that this is basically the same data, except that instead of tables and rows and columns, now we have classes, objects, and properties. And instead of a database, we will have a company object, which provides the employees list and the projects list, and we'll use those to do some queries. Now, in addition to that, we also have this helper method called print. It's actually a generic method so that we can use it to print different types of data. We'll use this to print out the results, and for each set of results, we'll also print out a label so that we know which query they belong to. We'll see how it works. Now, let's start with a simple example. We want to find the employees whose last name are Doe, and let me get rid of this. Okay, so let's say this is results. This is R1. Let's call it R1, and we want to find the employees whose last name are Doe, and that the employees are in the employees list of the company object. So we'll say something like this. We'll say from E in employees, where E dot last name is Doe. Yeah, something like that. And then we'll select E, and then we'll say print R1. We'll need to give it a label. Let's say this is Q1 query syntax, something like that. So let's run this. So this gives us John Doe and Jane Doe, which are correct. So John Doe and Jane Doe, whose last name are Doe. And let's do this with the method syntax. The method syntax will be something like this. We start with a collection, and then we say where, and we say we'll need to give it a lambda expression. We'll say E last name is Doe, and then we'll say select, and then we'll say select E itself, yeah, something like that, and this is the method syntax. So give us the same result. Notice that now is not ordered in the sense that it will print out the results in the order in the original collection. Okay, so this is a simple example. Let's add a few things. Let's first start with order by. So suppose we want to order the results by the employee first name. So in other words, instead of John and Jane, I want Jane to be in front of John. So if we do this with the query syntax, we can simply say OtherBy E dot first name, and if we use this one, we'll say OtherBy E dot first name, and if we run this, now Jane is in front. So again, notice the difference between LINQ and SQL. The key is LINQ deal with classes and objects and properties. So if we want to order something, we say object, then property name, object, property name, and so on. So this is OtherBy. Let's add projection. Projection, by the way, means selecting certain columns or certain properties in the case of LINQ instead of the whole thing. In SQL, instead of saying select star, we say select these columns, and that's called a projection. Same thing here. Instead of saying select the whole object, we say select only the first name and last name, and so on. So let's say we only want the first name and last name. Now, here we can use the tuple syntax, and we can say select first name and last name and combine them into a tuple. Remember the tuple syntax? We just put parentheses around. And here, let's use the anonymous type syntax, meaning that we're going to create an object, and this object will consist of first name and last name. And if we run it, instead of the whole object, we get just first name, last name. Notice that for the tuple syntax, it prints it out as a tuple, and for the anonymous type syntax, it prints it out like an object. Okay, so what else? Oh, occasionally you may want to do duplicate removal. If you remember SQL, you would say select distinct something. And same thing here, except that distinct is not is an extension method, but it doesn't have anything equivalent to in the query syntax. So we can do, for example, distinct here. And however, we cannot say select distinct. This one is not correct because, as I mentioned earlier, not all LINQ extension methods have equivalent part in the query syntax. Query syntax is just something built on top of the extension methods, but has less features. So if we want to do the same thing, we'll have to put our parentheses around this and put the distinct at the end, or we can do distinct here. Either way, it'll do the same thing. The key point here is that not all LINQ extension methods have equivalent query syntax. Okay, so the results are still the same because it's already distinct. Okay, so this is a simple query. The query itself is not complex, but I just want to use it to show a few additional things like OtherBy prediction and distinct. Okay, so now let's do this one. Find the leader of the project blue. So if you remember in the SQL example, the query for this is something like this. We'll say select E star from employees E, inner join projects P, P dot leader ID is E dot ID, where P dot name is blue, something like this. The point being that in SQL, if we want to do this, we'll need to do a join. But how about LINQ? Well, let's see. So in LINQ, we'll do something like this. We'll say from c.projects, from P in c.projects, where p.name is blue, select p. Oh, it's a little bit confusing switching back and forth between SQL and LINQ. So LINQ is C#, so the equal comparison is double equal symbol, and also strings are double quoted instead of single equal symbol in SQL and single quoting for string in SQL. Anyway, so we're going to select p.leader. And if we print this out, this one is Q2. This is the query syntax, and something like this. If we run this, we get Jen, who is the leader of the project Blue, which is great. Now, the main point of this example is that objects are different from relational data. In a relational database, tables are separate, so if we need information from more than one table, we need to do joins. However, objects are different in the sense that objects are often linked in the sense one object may reference another object, which may reference another object. Now, in this example, we can see that the leader of a project is actually a reference to an employee object. So here, we don't actually need to do a join. We can simply do a selection on the project and then use the object reference to get the employee object. And this is a general observation about query languages based on objects versus the SQL, which is based on relational data. Because of object references, we often don't need to do join in order to get additional data from other objects, unlike relational tables. So I'm going to skip the method syntax because it's going to be pretty much the same. Okay, so with that being said, occasionally we do need to do a join, even with objects. For example, here in this case, we can see that the supervisor part in our employee class is a supervisor ID instead of a reference to a supervisor object. So to find Jendo's supervisor, we'll actually need to do a join. The query syntax for join in LINQ is similar to the inner join syntax in SQL. So it will be something like from first item in collection 1, join second item in collection 2 on some key equals to another key, and then something. So let's try this. So we'll say from, what's the syntax? Yeah, from E1 in C.employees, and then join E2 in C.employees. Just like in SQL, we'll need to do a so-called self-join, basically the same collection join with itself. And then we say E1, let's say E1 is the employee and E2 is the supervisor. So we'll say E1 dot supervisor ID is E2 dot ID. Well, we have to say equals E2 ID. Okay, and then we need our where condition. We say where E1 dot first name is Jane and each E1 dot last name. Again, keep getting confused between SQL and LINQ, and E1 dot last name is no, and then we select E2 because we want the supervisor. And let's print this out and see what it looks like. So it is Q3, right? Yeah, it's Q3. So we're getting John Doe, which is indeed Jane supervisor, and so the result is correct. And this is how we can do a drawing in LINQ. Again, the query syntax is quite similar to SQL with some minor differences. So how about the method syntax? Well, let's see. Where is copy link? Okay, here. Okay, so this is how we can do a drawing in the method syntax. And if you look at this, API, it looks pretty complex, but it's a good practice for reading API. So let's give it a try. So this one, as the other LINQ methods, is a extension method. So we know that the first parameter of the extension method is important because this extension method will basically be called as if it's an instance method on the first parameter. So the first parameter basically says that it's a collection, an enumerable collection, and in this case, it's called outer. So then the inner one would be the collection that will be drawing it to. So what we do here is we'll start by giving it the outer one. So the outer one will be C employees. This would be the outer collection. And then the next variable is the inner collection. So, oh, by the way, this method is called join. So we'll say join, and then okay, yeah, it complains because we haven't put in any arguments yet. And then the second parameter is another collection, which is the inner collection, and in our case, it's this one. So we'll say employees again. And the third one is a delegate. So the third one is a delegate that says owner key. Okay, so it's basically asking which property matches which property. So in other words, this is trying to get this one, and it's a delegate, meaning that we have to write it in we have to give it a what's that thing called? Lambda expression. So we'll say first the key from the outer collection is E1 supervisor ID, and then this is the selecting the key in the outer collection, and this one select the key in the inner collection, which is another lambda expression. So that basically means this one. So we'll say e2 dot id, and then we'll need to give it another one, which is the result selector, and the result selector is a function that takes two arguments, outer and inner, and produce a result. Okay, so it will be something like this. E1 and E2, these are the two parameters, and it needs to return whatever we select, which is E2. So we will select E2. And this produces the drawing, and this the where part is and this is the result selector. Oh, here I think we need to select both, because otherwise later on we cannot do where. So drawing, and we may need to select both. Let me try this. We select both, and then we say right. So then we say E1's first name is Jim, and E1's last name is Joe, and then we select E2. Something like that. Let me give it a try. And this one will be the method syntax. And let's see what it produces. Okay, so it does produce Django, which is correct, but it takes a little bit figuring out in terms of the the syntax. but in any case, this is how to do it, and just need to get used to reading this weird-looking API. Okay, so moving on, let's do a example that uses set operations like intersect, except, and union, and also operations like single. So the idea of this query is that we want to find the employees who are on both project Firestone and project Blue. If we look at the project class, we can see the members of a project are in a list. So this basically requires the intersection of two lists. It's conceptually not too difficult, but there's a little bit tricky in one place. So let's say we want to first get all the employees who are working on project Firestone. So we'll say something like from M1 in C dot projects where no from P in C dot projects where P dot name is Firestone. This gives us a project, and like what we did with project leader, we can simply select P dot members. So this gives us all the members in the project Firestone. Now, here comes the tricky part. So just like in SQL, any query will return setup results. Even if there's only single result, it's still considered as in a collection because results can be more than one. In SQL, that means the results is always a table. Even there's only a single value in it, it's still considered a table with a single row and single column. And here in LINQ, even though the result is just one single list, it still be considered it a collection, meaning that the resulting list is actually one element in a collection. So this is where we'll need to use the so-called element operations. The elements operations let us to pick the results in a result set. We can pick a result at a certain index, we can pick the first one, we can pick the last one, and if we know for sure there's only one, we can say single. Now, in this case, we are going to say single because we know this one is for sure only has one list in the result set. Now, with this one, then we can use this to intersect the second part. And in other words, all the members in the first blue project. And again, here we'll need to use single to say that there's only one list in the results set. So our query would look something like this. Again, I'm going to skip the method syntax because it's very easy to convert this part into method syntax. And both single and intersect extension methods don't have equivalent query syntax. So in this case, we have to use these two methods directly. And then let's see, the result will be query number 4, and this one is the query syntax. And if we print it out, we see that John Doe is the only person in both projects. We can quickly check if that's the case. So members, John is in blue and John is in Firestone. So it's indeed the correct result. Set operations are actually something that we need to do quite common, and with LINQ, it's much easier to do than just to write a couple of nested loops and loop through two collections and try to find the common elements ourselves. Okay, so as in SQL, sometimes we want to do aggregations like count, sum, min, max, and so on. And as you may guess, there are LINQ methods for those. And let's see this example. So suppose we want to find the number of employees hired in 2015. And that should be 2. Only John and Jen were hired in 2015. The other 2 were hired in 2016. Okay, so the query would be something like this. We'll say from E in employees where E dot date hired, and we only need the year, so we use the year property in date time, and we say this one is 2015, and then we count. So here, if we so I guess we cannot count before we select. We select E and then we count. So we are getting 2 here, which is the correct result. And this is how we can do. This is how we can use aggregation functions. It's still a query, and again, I'm skipping the method syntax because it's easy to do this query in method syntax, and then apply the aggregation function. Now, after aggregation, naturally, we may be thinking if we could do groupby in LINQ. The answer is yes, but there's a big difference comparing to SQL. In LINQ, groupby does not require aggregation. It simply creates a bunch of groups, and each group is basically a dictionary. It's a key, and the value is a collection of elements. So the query syntax is simple enough. Let's see how we could use it to group the employees by the year when they are hired. We will say something like from E in employees, and then we say group E by date hired and year. Okay, so this will create a bunch of groups, and as we mentioned, the group is something like this. If we quickly look at the syntax, we can see that it's basically a collection itself. So we can use for each to iterate through it. We'll say for each group in int, we can write out the key of the group. So we'll say group.key. And then for values, it's another collection. So we'll need to do another one. And this one we'll call it, I guess we'll call it employee. And let's write this one out. So this gives us two groups. The first group has a key 2015 and has two elements, John and Doe, and the second group has the key 2016, two elements, Tom and Bob. Now, if we look at the method syntax for groupby, you can see that they are quite complex. So I'm not going to do the method syntax for this one. Feel free to try it yourself. If you figure it out, post your solution in the weekly discussion on Canvas, and you'll get some extra lab credit. And one more thing about LINQ is that the where method can be chained, meaning that we can put several where methods together. We can say something like a collection where something, then where something, and then where something, and so on. And this is a very useful feature for certain situations where we need to build up a query piece by piece. For example, suppose we allow people to search for employees by first name and or last name and or date year hired. A user can fill in all three fields for a more precise search or only one of the fields or any combination of them. You can see that it will be quite difficult to compose a SQL query because all the different combinations. But with LINQ, it's actually quite simple. So this is what the code would look like with LINQ. We can simply check each field, and if the field is not empty, we just add a where method. And if the next field is not empty, we'll add another where method, and so on. And because multiple where methods can be chained together, it's quite easy to compose a query by putting several conditions together. So this is the end of this video. Please check out chapter 13 of the Pro C# 9 book for more examples and discussion about LINQ. Thanks and see you in the next video.